Today's lesson is section 6.1, Graphing Systems of Equations. Systems of equations means graphing two equations that have two variables. When you graph two equations on the same coordinate plane, the solutions is the point at which both lines cross. Here is an example of two lines crossing at the point 1, 1. So the solution to these two equations crossing is the point 1, 1. In this graph, there are two lines that are parallel. They never cross. Now remember something about parallel lines. Parallel lines have the same slope. Parallel lines have the same slope. Now in this graph, it looks like there's only one equation, one line, but actually there are two equations. They just happen to be the exact same equation. For example, if the equation is y equals 1x plus 3, the other equation would also be y equals 1x plus 3. So when the graphs are on top of each other, therefore they would cross at this point, this point, this point, this point, all the points on the line they cross. So the answer is infinitely many solutions. Do not get that mixed up with all solutions. All solutions mean every point on the whole entire grid, where infinitely many solutions means only the points on the line. Example 2a, graph and state the solution. So we have two equations. We have to solve each one for y and then graph on the same coordinate plane. In this example, both equations are already solved for y. Y equals negative 3x plus 10. The equation, the slope is negative 3 over 1. Your y-intercept is 10, which is the ordered pair 0, 10. So if we're going to graph this, plot 0, 10, we're going to go down 3 to the right 1, down 3 to the right 1, okay, draw the line. Okay, the other equation, the slope is 1 over 1. Your y-intercept is negative 2, which is the ordered pair 0, negative 2. Plot 0, negative 2. And your slope is up 1 over 1. Okay, connect that line. Now you can see that the two lines cross at the ordered pair 3, 1. So the solution is 3, 1. That is your final answer. After you graph the two equations, you see where they cross, and that is the answer. Example 2b, the two equations are 2x minus y is equal to negative 1, and 4x minus 2y is equal to 6. We have to solve each equation for y. So the first equation, we're going to subtract 2x, get negative y is equal to negative 2x minus 1. Now remember, when you divide everything by a negative 1, it changes the sign. So that's y is equal to positive 2x plus 1. That is the first equation solved for y. The second equation, I'm going to subtract 4x. So that's negative 2y is equal to negative 4x plus 6. Divide by negative 2. And I get y is equal to positive 2x, minus 3. Now, in the very first equation, you will see that the slope is 2 over 1 and your y-intercept is 1. The second equation, your slope is 2 over 1 and your y-intercept is negative 3. I already know that they have the same slope, so they're going to be parallel. But let me go ahead and graph the 2 points. So 2 parallel lines never cross, therefore the answer is no solution. Or we could just simply say 0 and a slash through it. That means no solution. Okay, example 3, we have to solve each equation for y, so we're going to subtract 2x on both sides. So that's negative y is equal to negative 2x minus 1. Again, when we're dividing by negative 1, we change the sign, so that's y equals positive 2x plus 1. The second equation, we're going to subtract 4x on both sides. So that's negative 2y is equal to negative 4x plus 6. Divide by negative 2. And we get y is equal to 2x minus 3. Again, those are parallel. Okay, the next example, the first equation y equals negative 2x minus 3 is already solved. So the second equation, I just have to subtract 6x. It's 3y is equal to negative 6x minus 9. Divide by 3. So y is equal to negative 2x minus 3. Now, as you can see, these two equations are the exact same equation. They are two separate equations, but when we go to graph them, always make sure you label your x and y axis. As you will see, they're the exact same line. So the answer is not going to be infinitely many solutions. It's every single point that lands on the line. It's this point, this point, this point, this point. It's all the points that land on the line. So the way to say that is infinitely many solutions. Your homework is page 336, even numbers 16 through 24, and even 28 through 36. You'll look at your calendar to see exactly what page number. It is due the very next class meeting. Make sure you copy all of these examples down in your notebook. If you did not do that, you need to go back through all the slides and copy them down in your binder on graph paper.